Welcome back to this session number 10 from the playlist of motion in a straight line. The question for this session is written on this board here. And the question here is a bullet loses 1 by 20 of its velocity while passing through a plank. The least number of similar planks required to stop the bullet is. There are four options here 10, 11, 12 and 13. So these are the number of planks which are required to stop the bullet and we have to find the correct option. So in order to save the time, I have already drawn here one figure which depicts the arrangement of the similar planks here. So these are the planks which are attached to each other, and let us say the bullet hits this plank number 1 with a velocity u. Now, when it is written here that the bullet loses 1 by 20 of its velocity while passing through a plank. So when it passes through this plank number 1, it will lose 1 by 20 of its velocity. So the velocity when it after it leaves the plank number 1 will be equal to what? V is equal to u minus 1 by 20 of u, which is equal to u by 20. So v will be equal to 19 u by 20. So this is the velocity of the bullet when it leaves the plank number 1. Now here I have considered that the number of planks which are required to stop the bullet is small n, and when the bullet passes through this combination of n planks, then it is subjected to a constant retardation which is equal to a. So in this case, what I will be doing is I will be using the equation of motion for constant retardation, which is v square is equal to u square minus 2as, where s is the distance travelled by the bullet. Now when it passes through this plank number 1, it will cover the distance which will be equal to the thickness of the plank, and here I have taken the thickness of the plank as small t. This is the thickness, and since we are required to find the least number of similar planks which will stop the bullet, so the thickness of each and every plank will be the same, that is t. So here s will be equal to t because the bullet is passing through this distance. Now v is equal to 19 u by 20, and this will be whole square, and this is equal to u square, where u is the initial velocity with which this bullet has hit the plank number 1, minus 2 into a. A is the constant retardation to which this bullet will be subjected to while passing through this combination of n planks. A into s is the thickness, or you can say the distance travelled by this bullet while passing through the plank number 1. This is equal to t. So from this equation, what I will be getting the value of 280. So from this equation, the value of 280 will be equal to u square minus 19 u by 20 whole square. So this is equal to u square minus 19 u by 20 whole square. So here from this equation I will be getting the value of 280 as 400 u square minus 361 u square, which is equal to 39 u square divided by 400. So the value of 280 is equal to 39 u square by 400. Now I will be using the equation of motion in which the bullet will come to a halt after passing through some number of planks. So here the initial velocity of the bullet is u, the final velocity will be 0. So if I use the equation of motion for constant retardation, that is v square is equal to u square minus 2as, then in this case the initial velocity is u, final velocity is 0. So 0 square, this is equal to u square minus 2a. Now what is s? S will be the distance traveled by the bullet in passing to the N plank. Now here I have taken the number of planks required to stop the bullet is N. So the distance traveled by this bullet to before it comes to stop, the distance traveled by the bullet before it comes to stop will be equal to the number of planks, which is equal to N, multiplied by the thickness of each plank, which is equal to T. So S will be equal to number of planks N into T. So from this equation, what I am getting here is that 0 is equal to U square minus 2AT into N, into N. Or we can say that the number of planks required N is equal to U square divided by 2AT. Okay? From this equation. So finally, I have got two equations, that is 2AT is equal to 39 U square divided by 400, and the second equation is N is equal to U square divided by 2AT. So what I will be doing is, I will be substituting this value of 2AT in this equation, that is N is equal to U square divided by 2AT. So by doing so, what I will be getting is, that is by substituting the value of 2AT in this equation. Let us say this is the equation number. Let us say this is the equation number 1 and this is the equation number 2. So by substituting the value of 2AT in equation number 2, I will be getting the value of N as U square divided by, now 2AT is equal to 39 U square by 400. So this is 39 U square by 400. Now 400 will come into the numerator. So this is equal to U square and U square will get cancelled out. And finally what I will be getting is 400 divided by 39. Now 39 means that is 39 multiplied by 10 will be equal to 10. So this value will be slightly more than 10. So it is approximately equal to, I think, 10.25. So the value of N is coming to 10.25. Now, so what? So here we are supposed to find the least number of similar planks which are required to stop the bullet. So the least number of the planks which we will require to stop the bullet will be equal to 11, because 10 planks will not be able to stop it. The number of planks required is 10.25, more than 10. So more than 10 means the least number of similar planks will be equal to 11. So thank you very much for joining this session. I hope you have understood the solution of this question. And in the next session, I will be coming up with a different type of a question. And so till then, have a nice day. Bye.